Yeah, comes on everyone. So this was the last thing that we did. Let's start off with a problem. This is your top view. So we have two conducting rails. We have a battery, a resistor, and we have a rod. So the system is released from rest. These are smooth rails. Find velocity after time t. Wait, I forgot to give this magnetic field also. Find the velocity of the rod after time t. नहीं रे again. What happens here? As the rod starts moving, this will start generating an EMF of its own, isn't it? This EMF and the battery are fighting, and that EMF is not constant, that is changing with velocity. You have to integrate. Try, I'll give you a minute. So let's say after time t, this is going with velocity v. This is e, this is r. This will act like a battery BLV. Current I would flow through this. So E minus BLV minus IR is equal to 0. So we get current is equal to E minus BLV by R. And now if you draw the FBD of this rod, the forces will be ILB. That is only force acting. So ILB is equal to mass into acceleration. If you substitute here, minus BLV by R into L into V is equal to mass into acceleration. Minus BLV. This integration looks like a mess. Substituting I there. Hey, wait, what did I do? E
You wrote
minus BL.
LB instead of L.
Yeah, into LB. Then it is M into dV by dt. And it is fine. This is dV by E minus BLV is BL dt by MR. Yeah, done. Integration 0 to V and 0 to time. Minus 1 by BL on that. Right, Lakshita. Saina, did you get the same thing? You had some weird answer, but have a look at the steps. Mainly main integration does. Clear? Let's see one more. Turn in the page. Clear, na? Swastika, Vidyut, Yasha, Palaksh. Clear with this? We have a rod here. This is hinged at one corner. The rod is rotating with omega. The magnetic field is 0. Length is L. Second case, omega, but distance is the magnetic field B. This is O and this is A. Find BA minus BO. M is the mass of the electron. E is the charge of the electron. Clear? Clear the steps? You will get the notes right, push. Focus on learning now. Why you want to make a notes now? Let's get this, everyone. That is the question. Listen, I'll help you with the first thing. First thing, you don't have any magnetic force. But we did something like this where in current electricity we did transverse voltage. Do you remember? So when you have electrons here, the electrons here are experiencing a centrifugal force, which is m omega square x. This is too small. We can always neglect this, but there is a small thing we can calculate and see. This is the centrifugal force on the electron. That means all the electrons are accumulating on this corner here. This becomes negative charged, and this becomes positive charged. So these guys create a counter field E. So this is the electric field due to the induced charges. So these will act in the opposite direction. E. So from there we get electric field into E is equal to the centrifugal force m omega square x. So we get the field is equal to m omega square x by E. So the potential difference VO and A, VO minus VA or VA minus VO is minus integral E dot dr omega square dx by E. Limits will be VA is the final, so that is your L, and O is the initial, that is 0. Omega square L square by 2E. This is your potential difference. But if you see, here the MK value is 9 into 10 power minus 31. It is too small. Each electron 10 power minus 19, but that still will end up at 10 power minus 12. So therefore, this is negligible. So if there are other forces involved, we can neglect this. This is too small. We have seen something like this in transverse voltage. The question is, this question, page 35, current. Idea is similar. Clear, everyone? Now, what happens if there is a magnetic field? So if you have a magnetic field, take a small piece dx at a distance x. So I can treat this like a battery. So this point is going with velocity v is equal to x omega. So this entire rod consists of, so if you put a positive charge, it will go inside. So it will act like this. So each segment will act like a battery whose EMF dE will be b, length is dx, and velocity is x omega. So we get VO minus VA. Add all the EMFs, integral v omega x dx. V omega L square by 2. This is the potential difference between the ends of the rotating rod. Standard result. And the same way, how to get the direction? Assume a positive charge. See which way the charges are going. That will be the positive terminal. This is the potential difference between the axis and the end of the rod. If I take one more example, suppose if the rod is going this way and the magnetic field is this way, can you tell me which is the positive terminal? Assume a positive charge here. Velocity v is this way. So v cross b, the force is this way. So this is the positive terminal and this is the negative terminal. It's clear? The same way we used to do for a rod. Here also put a charge q. See which way it is traveling. That would be the positive terminal. All clear with this? Let's see one more like this. Any doubts on this? Rehan, clear with this? Utsa, you're there? Okay. We can't even see your head, right? Something happened. So we got a rod here. The lower part of the rod is made of wood and the upper part is made of metal. We have the magnetic field B here and the whole setup is rotating with omega. This is length L. This is also length L. This is A and this is B. Find VA minus VB. We have a rod with some weird shape. This is hinged here. This is O and this is A. And this whole setup is rotating with omega. Find VO minus VA. We have a V-shaped rod, theta. This is L and this is L. This whole setup is rotating with omega. This is O, this is A, and this is B. Find VA minus VB. Get them all. Right, Saina.
डी पार्ट में ओए का लेंथ क्या है?
Give me answer in terms of OA. Leave the answer in terms of OA. Bus. So this, what you can do, there are two ways you can do. Either we can take this integration here and change the limits. So here the limits were 0 to L. Here you can put the limits from L to 12. Or take a rod of length 12, take a rod of length L, and subtract now. So the catch here is, in a wood there are no free electrons, so there'll be no conduction in it, isn't it? So you can take a rod of length 12 and L and finish it off. So this guy would be, this is B omega 2L whole square by 2. This guy would be Bm omega L square by 2. So if you subtract them, who is positive here? If we put a positive charge V this way, V cross B, force is upward. So we get a VA minus VB is equal to 3 by 2 B omega L square. What about D? In case D, complete the loop. So the flux in the loop O, A, O, there is a flux, but this is constant, isn't it? No matter how much the loop rotates, will the flux change? The flux won't change. Therefore, EMF in the loop is zero. That means EMF from O to A plus EMF in A to O must be equal. Projected length. Basically, you can replace the whole rod with a length, and so this problem can be replaced with that. If you put a positive charge, it goes to the left. So VO minus VA is B omega. Length का place में भी take OA का length square by 2. So OA is your projected length. It doesn't matter what is the shape, because if you complete the loop, the total flux is zero. Therefore, the EMF must be in the opposite directions. Clear with this? So that whole curved rod will behave like a straight rod. So this produces EMF like this. This also produces EMF like this, and both are cancelling out. Is the D part clear, everyone? So how will you do the? Oh shit! I wrote reverse. Hmm. Clear? Show you the E part of the question. Length L, theta. This whole thing is rotating with omega. This is your magnetic field. This is O, this is A, and this is B. Find VA minus BB. B omega 12, this thing. Projectile length makes you happy. Happens. That thing comes a lot. E0 नहीं रे, E0 नहीं है. Again, the same idea which you have taken. If I complete the loop, You cannot find for AB directly. I think, Aryan. Let's see. So EMF in the loop is 0. Why? Flux is constant. If you complete that loop, O, A, B, O, that is 0. That means EMF from O to A plus EMF from A to B plus EMF from B to O must be 0. So O to A will be how much? B omega L square by 2. Again, you have to be careful. If I put a plus charge Q here, it goes this way. So yeah, O is positive plus EAB. Now, when you go from B to O, if you put a plus charge, O is positive. So this is actually minus B omega. The projector length will be how much? 2L sine theta by 2 cos square by 2 equal to 0. So therefore, A to B must be the balance. So B omega by 2, 2L sine theta by 2 whole square minus B omega L square by 2. Check. I think, Aryan, you found from O to B, I guess. Yeah. So that's it. So be careful. So you have to treat, right? You have to make sure. So here also, if you put a plus Q charge on this guy and velocity V is this way, it will be that way. Signs are important. Just be careful with that. And that length OB will be how much? 12 sine theta by 2. I hope you know how to do that. Drop a perpendicular and you got an half angle. Clear? Any doubt on this? This is a good one. Every time you won't get a proper rod rotating. Let's see one more. Suppose we got a rod here. This is going with V2. This is going with V1. And let's say V2 is greater than V1 and there's a magnetic field B and the length is L. These kind of velocities are possible when the rod rotates and translates. This is A, this is B. Find VB minus VA. We have a rod like this length L. This is theta. There is a magnetic field B. This is point A. Someone is pulling this with speed U, constant. And this is B. We have done this in mechanics. Again, find VB minus VA. How is this related to rotation? IAR. If you go and stand on the IAR, suddenly it starts feeling like a rod. Page 170, rotation mechanics. There are 3 cases on how to find IAR. So if I give you a general solution, see, let's say if we got a rod like this is going with V1, theta 1, This is going with v2, theta 2. You know how to find IR, isn't it? So for this velocity, drop a perpendicular. And for this velocity, drop a perpendicular. The point where they meet is your IIR, isn't it? So I can call this point O, I can call this B, and I can call this point A. So if I construct an imaginary loop here, right? I can construct an imaginary loop and I can find O to A ka potential, O to B ka potential. The difference must be A to B ka potential, isn't it? Because the total EMF in the loop is 0. Now, if this length was L1 and if this length was L2, meaning using geometry, you can calculate. And this would give you VA minus VO would be B omega L1 square by 2. Similarly, VB minus VO will be B omega L2 square by 2. You have to check your directions, depends on the magnetic field. Right, and then you're done. So subtract them, VA minus VB. And how to get omega? Omega is nothing but V1 by L1 or V2 by L2, the perpendicular distance. Both will give you the same thing. Clear? So if the rod is going at some weird angles and all, this IR will work. Now, this is a first one is a special case. If both the velocities are parallel, this was V2, this was V1. That means the IIR must be somewhere on this line. Let this distance be X. This distance is L. For both of them, what is same? Omega. So omega must be V2 by L plus X, and this is V1 by X. So from here we get X ka value. V1 into L by V2 minus V1. Right? That is your X. And omega would be V2 minus V1 by L. So this is O, this is A, and that is B. And since V2 is greater than V1, this whole setup is rotating with omega. This is your magnetic field. So if you put a positive charge, it is going up. So my B is positive. So VB minus VO is B omega L plus X whole square by 2. VA minus V omega. So the point is the formula we derived is always from the center, isn't it? Or you can take the limits here. This is, you can take a small dx and change the limits from x to L plus X. B omega X square by 2. There, from there you get VB minus VA. Is this clear, everyone? Because you already know how to find the result if the center is hinged. So just create a center then. Any doubts on this? Clear, everyone? Can you do for G now? This we have seen this thing in NLM. A metal rod, conducting rod is sliding. And someone is pulling the day with a constant speed u. Find the potential difference between A and B. First thing you had to find the IAR. So this is going with U. This is B. B is going with some velocity. It's fine. We don't need to know that. So drop a perpendicular from here. That's all. Look at IR. Find 2 points whose velocities you know, and drop the perpendicular for both the velocities. And the point where they meet must be the center. So the whole idea is when you say an IIR, means you're assuming all points are going in concentric circles. So for any circle, if you draw two normals, they will always meet at the center. Isn't it? Isn't that the meaning of IIR? When you go and stand on the IIR, you think every point on the rod is going in a circle. Different circles of different radius. But all are concentric circles. So if you draw normal for any two circles, they should meet at the center. So this is theta. This length is L. And so this length would be L sine theta. And this length will be L cos theta. And this point is O. Omega will be U by L sine theta. And then you can just treat OA as a rod. So VA minus VO would be B omega L cos sine theta square by 2. VB minus VO would be B omega by 2 L cos theta square. If you subtract them, VB minus VA, that will be cos square theta minus sine square theta. That will be B omega L square by 2 cos 2 theta. Clear? Yeah, right, Yasha, you got that. You stand on the IR and you're done. These things become quite easy to handle. You should definitely go back to IR and see in case you forgot. That was also a good question in IR. We know what we did. The question was find the kinetic energy of this rod. You can't find kinetic energy of this rod normally. It's very complex. Is this clear? Any doubts on this thing? Please ask me. Let's see one more. We have a conducting ring which is rolling without slipping. There is a magnetic field B. This is the point A. This is some point B. And the angle between them is theta. Find VA minus VB. So it's a conducting ring rolling, and going. If it was only translating, your life would have been easy. So A to B, you can treat this as two projected lengths and find EMF. But this is rotating also. How will we do this? A is the topmost point. Try. I'll give you a minute. Okay. 1 minus cos theta. Yeah, not chance रहा है. Maybe you're right. Let's see. You didn't get a R square, right, Lakshika? Dimensions देखो एक बार. So look at this thing again, the same concept. It is difficult to see this thing when it is rolling and translating everything. So just let's go and stand on the IIR. Where is IIR? IIR will be the bottommost point. So if you just go and stand on IIR, suddenly the problem becomes like this is one rod and this is one rod. Isn't it pure rotation? So you're trying to convert all these problems into a pure rotation. Right? So this angle is theta. So this would be 180 minus theta. So that would be 90 minus theta, and this is r. So this is r cos theta and r cos theta. So VA minus VO would be B omega 2r whole square by 2. Whereas VB minus VO. So basically you're just treating the O as the hinge. And you're treating O as a rod. Let's call this O, IR. And OB is another rod. B omega 2r cos theta by 2, na? Theta by 2. Cos theta by 2 whole square by 2. Subtract them. P omega r square by 2, that would be 1 minus 2b आएगा. That is 4 is 1 minus cos square theta by 2. 2b omega r square sine square theta by 2. Yeah. Alright, Lakshika, you are right only on that thing. So 1 minus cos theta becomes 2 sine square theta by 2. Clear? So you see things like this, the rod is going at weird angles, the rod is rotating, rolling. Just stop the body, find IR and finish it off. Clear, everyone? So all these are again one type of models, the rod rotating. So I kept them together. Let's see one more like this. Any doubts on this?
Yes, sir, quite a few.
क्या doubt है?
So first of all, वो IR कैसे आया आपको नीचे वाला point?
Yeah. Next one. You should go and refer the rotation का notes.
Yes, I should. And also, sir, on the geometry part, I did not understand any one angle. So theta by what? How did you take that 90 minus theta by 2?
ये
And
दोनों
then,
symmetry होगा ना 90 minus theta by 2 90 minus theta 2 because total is 180.
sir, what point have you dropped the perpendicular on? मतलब क्या है चीज क्या है वो the green dotted line?
Just find the length ना रे अभी इतना geometry how will I teach you? You understand EMF, you understand Faraday's law. The triangle का length निकालना नहीं आ रहा है मैं क्या कर रहा हूँ?
अच्छा, okay, sorry, got it. I
ये
know
क्या
what I'm
था? R and R 90 minus theta by 2 90 minus theta by 2.
yes, I got it. I don't know what I thought over there. IAR and equal 0.
हाँ तो IR देख के बाकी सब फ्यूज उड़ गया. देखो IR के जाके देखो we spent almost half class in that IR only and you're simply asking sir IR कैसा होता है. Do that, check it out, it's a pretty important one. IR कभी भी आता है ना, always pretty tough questions. Next one, top view. We have a conducting ring. So we have a rod here. This is hinged at the center. This whole setup is rotating with omega. You attached a resistance R. And you connect it to the center. So radius of the is A. The resistance of the rod is R. So rod का resistance is also R and the external resistance is also R. So this is O, this is A, and this is B. Magnetic field is B this way. Find BO minus BA. So basically the edges of the rod slide on the ring. Is the diagram clear? It's like if you see my screen, right? If this was the ring kind of thing, and this is the rod. So this thing rod is gliding on this. The edges of the rod is gliding on this. And the side view would have looked something like this maybe. So after some time the rod will be like this. After some time the rod will be like this. So the rod is rotating on it. Diagram is clear? What you're seeing is the top view. Maybe I should change the color of the rod. How do we do this? Cannot directly say B omega L square by 2. Don't forget, B omega L square is EMF. EMF is different from potential difference. Till now, you didn't have a problem because there was no current in the circuit. All the problems you did, there was no current. 3 omega B square by 10. Okay, let's see. I don't remember the answer. Could be right. Try. I'll give another minute. Resistance of the rod is R. They'll say like that only. They won't mention more. So you know the full rod is R. So what's the catch here? See, the idea here is the mistake what people do. Now this whole rod will act like two batteries. And which way it is that? So assume a positive charge, V cross B, fair enough. So this is acting like a battery here, and this is acting like a battery here. EMF E and EMF E. So if you try to draw the circuit, this is how the circuit looks. So the each segment this is your circuit. This is O, this is A, this is B. This resistance is R, this is EMF E, this is EMF E. This will be R by 2 and this will be R by 2. Is that making sense? EMF E will be given by B omega A square by 2. So that each segment will act like a battery with an internal resistance. It is given the whole rod ka resistance is R. Matlab OA ka resistance and OB ka resistance is R by 2 each. So now if I try to solve this circuit, let this current be I, let this current be I, so this current will be 2I. Apply Kirchhoff's loop law. We get E minus 2IR minus I into R by 2 is equal to 0. So I is equal to 2E by 5R. You want potential difference between O and A. So VO you're going opposite to the battery minus E plus IR by 2, you reached VA. So we get VO minus VA is E minus IR by 2. You have to include the potential difference across that internal resistance. IR is how much? I is 2E by 5R. Four E by 5. That would be 2B omega A square by 5. 3 by 10 kahan se aaya hai? Or did I goof up something? Is the circuit clear, everyone? That each segment will generate EMF. Fair enough. But each segment also has a resistance R by 2. So this whole thing will act like one battery. This will act like one battery. This entire wire, this entire ring is there, that is this wire. Isn't it? That entire conducting ring is that green wire there. And you're connecting the resistors between O and that conducting ring. So between O and this conducting ring, the green one. Everyone got the circuit? That's it. Once you got the circuit, it becomes a current electricity equation. Clear, Anusha? How do we get the directions? How do we do that? Put a positive charge, velocity V, QV cross B. It is going towards O. So O is the positive terminal. B का भी वही होगा. Put a charge here, Q, velocity is this way. God. You guys have weird doubts, right? You guys understand big things. You know, when you ask such things, what I feel like? If I ask you some questions about, Ramayana, like, what kind of person is Ravan, you will tell. What kind of person is that some Sugriva, you will tell. You'll ask everything. But in the end, you ask me, sir, like, why did, what is the relation between Ram and Sita? Like, he has to go that far. You know every damn thing about every character. You just don't know what is the relation between Ram and Sita. मुझे ऐसा लगता है sometimes the kind of things you ask ना ठीक है happens maybe too much information brain gets short circuited. My sister does that. मतलब, we used to go to movie when we were in school. She used to sleep through the entire movie. She used to wake up in the middle of the movie and like, what happened? I said, nothing happened. Sleep. Go back to sleep. I used to wake her up during break ka time. We used to get her popcorn, cold drink. She used to drink and sleep again. It's a complete waste of movie ticket for her. But we can't leave her alone at home, na? So we used to take. Top view. This time we have a rod here. I forgot to tell you here, na, I can create one more case here. Yeah, not a big thing. Suppose instead of a rod, right, if you take a full disc and the whole disc is rotating. So this is not really that different from the other problems. You can simply treat this as multiple batteries like this. You're getting it how it is. So you can just treat this as a bunch of batteries in parallel. So each battery ka EMF is B omega R square by 2. This would be over here and all these points will be like identical. Clear? If someone tells you, right, a disk is rotating with omega, find the potential difference between the circumference and the center. So what we're doing is literally we're cutting here and we are just folding the disk into a rod, isn't it? And if you see in the EMF, it doesn't matter what is the thickness of the rod. Only what matters was the omega and the radius. So just in case, so you might think like, "Arey, yaar, disk de diya, to what will be different?" Nothing different it is. It is just a bunch of batteries in parallel, so it will be still the same. Clear? So that is same as this guy. That is one. There'll be infinite batteries now because you can take thin segments and each segment will act like a battery. So we can't solve. There'll be infinite batteries. If you want to ask, a better question would be like, cycle ka wheel has spokes. It has 24 spokes. They'll say something like that. Now they can say each spoke has an internal resistance smaller. So then you have 24 batteries with internal resistance R. Then it becomes important how many batteries are there if you have internal resistance. Remember combination of batteries in parallel? So if you have internal resistance, number of batteries become important. If there is no internal resistance, you keep million batteries, it doesn't matter. Potential difference is constant. So we have a rod here, top view. So the rod is sliding on this conducting ring. We have a resistor R. This is connected to the center. This is out of the plane. So the magnetic field is B in the region. So someone gave this rod initially omega naught. Mass of the rod is M, length is L. There's no resistance to the rod. Mass M, length L, rod has no resistance. So initially rod is given omega naught. Find omega as function of time t. Something happens and the rod starts slowing down. This is a top view, so you can neglect any gravity. It doesn't matter anyway. Find the angular velocity omega after time t. For some reason, the rod slows down. Obviously, it slows down. Why? Think about it. When there's a current in the circuit, resistor is producing heat. Where is all this energy coming from? It has to come from somewhere. Find omega as function of time t and the total heat produced. Let's get this. Why is the rod slowing down? See, if you draw the circuit, you'll realize again how to get the direction. Put a positive charge, velocity v, qb cross b, so the force is to the left. So this is acting like a battery of EMF E, and at any instant let the velocity be omega. So we get EMF is equal to B omega L square by 2. So current in the rod will be E by R. Now, if you look at this rod, at a distance x, if you take a small piece dx, so we are having current I this way and the magnetic field B is this way. What is IL cross B? Sorry, current is going the other way. Current is going this way and the magnetic field is B this way. So that means now we got a current carrying rod which is moving in a magnetic field. So this will experience a force like this, which is I into length into magnetic field. So this small rod will have a torque, which is x into df. So the total torque acting on the rod will be integral d tau, which is I into b into dx into x. This will go from 0 to L. So we get the torque on the rod will be IB L square by 2. But I is nothing but EMF by R. This is B omega L square by 2R. So this would be B square omega L power 4 by 4R. This is the torque acting as function of omega. So the faster the rod rotates, the more torque you will have. So this thing, if you see, torque is this way. So this thing creates an angular acceleration alpha this way and omega is this way. So this torque is actually slowing down the rod. And then we know torque is equal to I alpha B square omega L power 4 by 4R. I is nothing but ml square by 3. Alpha is minus d omega by dt because it's decelerating. This would be B square omega L power 4 by 4R. So this would be d omega by omega. L square will cancel. You have minus 3b square L square by 4mr into dt. Integrate omega naught to omega 0 to t. This would be your final answer. Omega is equal to omega naught into e power minus 3b square L square time by 4m resistance. This rod will take infinite time to stop. This function is killing itself. The slower the rod rotates, lesser the current. Lesser the current, lesser the torque. Lesser the torque, the even slower it will decelerate. So the function is slowly decaying. It takes infinite time to stop. And what's the total heat produced? That's the easiest one. Half I omega square. Yeah, all the kinetic energy in the rod becomes heat. You want, you can integrate. You can say I square R dt from 0 to infinity. But when you calculate that, interestingly, you'll end up with half I omega square. I will be ml square by 3, isn't it? Logically think about it. All the heat that you got must be from the kinetic energy of the rod. There is no one else to give you energy. Clear, everyone? So that is about the motional EMF. So we saw when it was translating, now we saw when it is rotating. So if you're solving HCV or something, you can do first 60 problems till now. HCV has around 98 questions, I guess. So you can start doing, don't wait for the chapter to get over. You'll be able to handle more than 50% of the questions. Just based on motional EMF and this thing. Next thing, going ahead. So the next part is your induced electric field. Kush.
So I was asking, like, wait for a minute. I was just trying to.
You're checking the integrations or the concept.
The concept.
Concept to kuch nahi. Current, torque, physics got over here. If you're checking integrations, then definitely your max teacher should beat you right and left. I'm sure integration you start seeing monsters. This thing is like a cute mosquito. Clear? Next thing. Now the biggest thing is, or the confusion you can say, Faraday is saying, boss, whenever there's a changing magnetic field, you're getting an EMF, electric EMF. But how did the magnetic field create an electric EMF? So we have our time varying magnetic field. Something happened in the middle, which we have no clue. And then eventually the output is, we saw EMF. So this is electric potential. See, one thing is clear, magnetic field cannot create electric potential. They have no relation only. It is like saying gravitation field is creating electric potential. It doesn't make sense. Gravitation field will create gravitational potential. So that means we are missing something in the story. Like I said, Faraday didn't know why this was happening. All that he know was he saw the starting and he saw the end product. He didn't know what was happening in the middle. So the only thing you can conclude is this must be due to electric field. Electric potential can be created only by electric field. So from here, somewhere we have a doubt. So maybe somehow this magnetic field must be, an electric field must be created in the system. An electric field must be created. Which produces EMF. But with this as a conclusion, we go start searching for that. Generally, that is how theory works. Einstein, when he was working on his theory of, he was working on theory of some nuclear particles and all, and this guy faced a problem. So when he was trying to balance the equation, something like, two reactions A plus B is equal to C plus D, he needed to find a particle here, right? And one second. So he needed to find a particle to balance this. Now this particle, the problem was, if you want to balance the mass, this particle should have the mass of an electron. So if you put an electron here, mass is getting balanced on both the sides. But if you want to balance the charge, I have to keep a proton. Then the charge is getting balanced. He said, yeah, if I keep a proton, mass, law of conservation of mass is gone. If I put an electron, law of conservation of charge is gone. And then he said, yeah, there should be a particle which has a mass of an electron but charge of a proton. And he completed the theory and it worked. You getting it? So then they said, yeah, then people started searching for this particle. And I think after 5 years, they found it. They call it positron. These particles exist, antimatter. These are the particles which have the mass of an electron but charge of a proton. And Einstein, if you see the reason, right? If you ask Einstein, like, yeah, what made you think that way? And Einstein is actually a strong believer of God. And he said, this is what his meaning is. He said, God creates everything in symmetry. And for my theory to be symmetrical, there should exist a particle, or else this whole thing will go for a mess. Therefore, particle exists. And continue with the theory. So that way. And one of the reasons why Einstein never liked quantum mechanics, he found it weird. He found it is not symmetrical. So yeah. And then later on, when he's on his end of the days, right, he realized like, yeah, it makes sense. But by then it is too late to do anything. It's fine. So with this as a conclusion, so one thing we are clear, this magnetic field is somehow creating electric field. Now we don't know why, but it is creating that much field. Now let's go and try to find out how much is that. So now we limit our study to very special cases. So we study induced electric field. The concept, once you get the main idea that it is pretty easy to solve, only the starting part will look little thing, a little weird. So we study induced electric field due to cylindrical magnetic field regions. So we will limit our study to very specific cases. And why cylinder? All points are equidistant from the axis. That is one. And if you take an infinite cylinder, and for infinity, the special thing is every point is a midpoint. So we are trying to study these kind of fields. And if you look at this in the top view, the field is coming out. These kind of fields you can create from solenoids. So this is how we will start. Consider a cylindrical region of radius r. This is your top view. Consider a loop of radius r, and let's say the magnetic field in the region is B of t, something is changing with time. So, and consider a loop of radius small r, imaginary loop. First we will take inside r less than r. So Faraday's law, EMF in the loop is given by minus d phi by dt. Here area is constant, so this is minus a dB by dt. Correct? So we got the EMF. Now this is due to the electric field. This EMF what we are getting is due to electric field. Now if you look at this from the side view, you have considered this loop here. So the thing is, now this electric field which you got, I don't know how is this electric field. So one, it can be this way, radially. Remember, any vector can be divided into three components, I cap, j cap, three perpendicular components. It could be this way, or it could be this way, or it could be this way. Make sense? So I can write electric field in three different directions. So it could be a resultant of these three, isn't it? So let the electric field, we have three perpendicular components. Since you don't know which way it is, so let it be an I cap, j cap, k cap. Three components. So first one, E1 is the radial direction away from the axis. E2 is along the axis. And E3 is tangential. Makes sense? So it could be one of them, it can be all of them, anything. Now, if you take this thing, let's study about each one first. Let's study that E1 guy. Suppose if E1 exists, consider a Gaussian surface.
Sir, can I show the previous page?
Clear? Consider a Gaussian surface. So if you have a Gaussian surface, you're saying the E1 is radial, so E1 is acting like this in all directions. So the electric flux will be E1 into 2 pi r into L. Agreed? But this should be equal to charge enclosed by epsilon. How much charge is there inside? There's no charge. Since Q is 0, E1 must be 0. This field can't exist. This kind of field cannot exist. If you say there's a radial field, then there should be a charge inside. The second thing. Now, if you see, we know when the field is changing, the EMF is only in the plane. So if you look at in the vertical direction, there is no EMF. And if you think about it, aren't all these points identical? All these points are equidistant, right? Shouldn't they have same potential? That means all are equipotential, isn't it? All the points at a distance r from the axis are symmetrical. That means all the points have same potential. If you have same potential and if you have field E2, that means what will happen? There is a potential difference along the axis. Then the whole meaning of symmetry goes off. You are saying every point is identical at a distance r, and that means they all have same potential. So E2 also cannot exist. So when you take the ring here, or when you take the ring here, or when you take the ring here, all these points are identical. That means they have same potential. And if it's equipotential, you cannot have field in that region. Therefore, field along axis must be 0. Therefore, E2 also cannot exist. The only thing that is left is E3. That means the field has to be tangential. Is this clear? Now, have a look at this. So this is how we proved that the field can be in 3 directions. We proved 2 directions cannot exist. So from this we can conclude, therefore the field has to be tangential. Again, this we are proving only for cylindrical magnetic field regions. If you take any other shape, maybe the other components might exist. I don't know. Maybe E1 might exist. But we proved for this. And like I said, we will stick to mostly this much only. We will not study other types of regions. Very complex to study. Clear?
So,
Kush.
so like, is there any way to say like why in the radial direction no, sorry, why along the loop it should exist? Like, हमने E2 and E3 को like वो prove किया कि it doesn't exist and that's why like it has to exist like in that direction. Indirectly नहीं
See,
बोल सकते क्या?
one thing is clear. You said electric field is existing. That can have I cap, J cap, K cap, and two components are zero. Then if that is also zero, then where is the electric field? You started the whole story saying there is something. Right? So let's try to calculate. अगर ये भी zero हो गया, that means something is definitely wrong. We are dealing with something completely unknown. Now, so from here we know the EMF is minus d phi by dt. So this is nothing but your E tangential dot dl. This becomes E tangential. So we can write E dl is nothing but d phi by dt. And direction of this electric field is given by Lenz's law. Same story. The system will try to, because if you remember, the current J bar is equal to sigma E bar. Remember from current electricity? And J is what? J is the direction of the current. That means in the direction of the current, your electric field also exists. So if you can find the direction of the current using Lenz's law, that will be the direction of the electric field also. Clear? Let me show an example. I'll just put it as T. Turn in the page. Now, like I said, the problems are quite easy on this. Matlab, finding field is quite easy once you know till here. So let's say we have a cylindrical region. Up to R. And let's say magnetic field is B is equal to B naught into T. So first take a small loop up to R. So first thing, flux will be B naught into T pi R square. So EMF will be minus d phi by dt. So integral d tangential dot dl is equal to d phi by dt. So that's the thing. Basically, E dot dl minus E dot dl is equal to minus d phi by dt. Minus minus cancels out. You can say like that also. This would be E into dl will be 2 pi r, and d phi by dt will be B naught into pi r square. So we get the field is given by B naught R by 2. And once you take the thing R greater than R, now here the flux will be only up to capital R. So this is B naught T into pi R square. Again, same story. Integral E dot dl is d phi by dt. This would be E into 2 pi into small r is equal to B naught into pi into capital R square. This is B naught into R square by 2 small r. And what about the direction? Like I said, from Lenz's law, here flux is increasing. So B induced opposes. Therefore, B induced must be out of the plane. So this is anti-clockwise. Interestingly, we will get, so we have field lines like this. So we have concentric circles and the field lines are going anti-clockwise. We have never dealt with field lines like this. These are circular field lines. They form closed loops. We will talk about that later on. So if you try to plot the graph between field versus R graph, it's a linear graph and then it decays. Clear, everyone? So straightforward, find a loop, find the flux, differentiate equal to E dot dl. E will come out of the integral because it is uniform. dl become 2 pi r every time.
Can we to the previous?
Clear? Have a look at the example. Let's see a problem like this. Have a look at the steps what we did. Clear? Going ahead. Let's say we have a region like this. Here the field is into the plane, and here the field is out of the plane. So the inner radius is r, outer radius is 2r. Top view. So the magnetic field B is given by B naught into time minus k cap. This is for r less than r. And this is B naught t plus k cap, same value, but the direction has changed for r between 2r to r. And it is 0 for r greater than 2r. Plot electric field versus r graph. R is the distance from the center. Idea is the same. So here you'll take three regions, right? For r less than r between 2r and r greater than 2r. Take a loop, E dot dl, flux, differentiate, finish it. Try, I'll give you 2 minutes. Hope the question is clear, everyone. Give it a try. I'm just back in a minute. एंगुलर हाइपरबोला बस, और कुछ शेप ही नहीं है. There are three parts to the graph record. साइना, बट वो R to 2R का ग्राफ कैसे दिखेगा? Thing is, we know it is decreasing. Is it decreasing like this? It is decreasing like this. Downward concavity or upward convexity, whatever you want to call it, max. Because options में हर बार they'll play with that only. Everyone knows it is decreasing. Remember वो flux का first question में what we did? वही problem था वही पे भी. Everyone knows when it is coming out, it is decreasing. But is it decreasing this way or this way? Show you? Okay. Let's see. So if you take for R less than R, the flux will be B naught into T into pi R square. E into 2 pi R is equal to B naught into pi R square. P is equal to B naught R by 2. So that's a linear function. Now R between 2R and R. So that means if you're taking somewhere here at a distance R, so here the flux will be B naught into T pi R square minus. So I'm considering the downward thing as a positive still, okay? One second. So B naught T pi R square, I'm still taking the downward flux as positive. And what will be this flux here? This would be B naught into T. What will be that area now? Sorry, this is pi capital R square. Minus pi small r square minus pi capital R square. Agreed? So that would be, you're getting basically this flux, right? I'm taking it as negative between R to capital R to small r. So this would be 2B naught T pi capital R square minus B naught T pi small r square. Is that clear? So same story again in E dot dl is equal to d phi by dt. So this is E into 2 pi r, and this would be B naught pi pi will cancel. You will get B naught by 2. This would be r square by small r 2 times minus r. No? So I can just send the 2 also inside. So B naught pi is gone, 2 is gone. So B naught, this would be r square by r minus r by 2. That is your field. No, that's not some parabola to nahi hai. It is some weird function it is. It's a decreasing function. That's not a parabola here. And you can clearly see here when E is 0, R would be R root 2. So that means that R root 2, the sign will change for the electric field. So the electrical will go in one direction and then suddenly it will start rotating in the other direction. And you can clearly see here initially, so flux is increasing. The B induced must be out of the plane. So initially the field lines will look like this. They're going anti-clockwise. And exactly at R root 2, the field lines will flip. You getting it? The electric field direction changes. What is the meaning of negative sign? The E becomes negative. The direction will change. Is that clear, everyone? Question abhi tak hua nahi. So if you go for R greater than 2R, the flux will be B naught into T into pi R square minus this will be 3B naught T into pi R square. So the minus sign simply indicates the direction we have taken. So we are taking the downward, the field is going down, that is positive. E dot dl is equal to d phi by dt. So this would be E into 2 pi R minus 2B naught pi R square. B naught R square by small r. Clear? 3. Yeah. Clear, everyone? Now how to plot the graph? So if you try to plot E versus R graph, first it is increasing linearly. And then if you look at this function here, if I just differentiate this, dE by dr, that would be minus R square by R square minus F. So if R is increasing, so slope is negative. And if R is increasing, slope decreases. Isn't it? So that curve should have a negative slope and a decreasing one. Meaning if I have like this, the problem is the slope is negative, but the slope is increasing. So it should go something like this. At this point is R root 2. That is where the field touches 0. This will go till 2R and then the function will decay. This is how the graph would look. Is that clear, everyone? So the second part of the graph, you have a decreasing function whose slope is negative and the slope ka value is tending towards 0. 0 nahi, exactly. If R small r tends to infinity, the slope should become minus half types. So it is decreasing, that much I know. And after that, it's a 1 by R function. Clear, everyone? So it's like you can find something, we have done something like this in Ampere's law, where it is mu naught into y. Idea is a similar one. Taking loops is not new, right? We have done this in Gauss law, we have done this in Ampere's law, this is the third time. Let's see one more. Any doubts on this page? Please ask me. Next one. Top view. We have magnetic field B is equal to B naught T square. In the middle, you fixed this light rod. And you attached a plus Q charge and mass M. And this radius is R by 2. So that length of the rod, we'll just take it as L. The length of the rod is L. Initially, it is at rest. Find the tension in the rod as function of time t. The rod is hinged at center. Then the other end has a charge q and mass m. Initially at rest. Find the tension in the rod at time t. How do you find which way it is going? Force is equal to charge into field. Whichever is the field direction, charge will go in that direction. It's a positive charge. First of all, who the hell is moving the positive charge? Can magnetic field move a stationary charge? No. So this magnetic field is creating electric field, and that electric field is accelerating this. How do you find the
magnetic
direction
field
of
also come
field?
into play, no? After once this
Yeah,
did you take that also?
I don't know. You tell me. Exam
Can
whom will you
ignore
go
it.
and ask? Ignore it then. Then we'll get a wrong answer. So we will say it is minus one. उसमें क्या है? You have to use Lenz law, right? Nah, Saina. You just need to use Lenz law to find the direction. Assume the flux is increasing or decreasing. That will give the direction of current, right? Normally. That's what I'm saying. In the direction of the current, your electric field also will be there. J is equal to sigma E. That's what I was trying to tell. So you can use Lenz law to find the direction of field. So see, flux is increasing or decreasing. Support or oppose. And then put B into its direction. Then use right hand rule. Try. I'll give you a minute more. So first find the electric field. Then find the velocity. MQ near it. अच्छा आंसर नहीं आएगा. MQ dimensions भी मैच नहीं हो रहे रे God. Question is tension. Charge into mass is not tension. First find the electric field as function of time t. You will get a time varying electric field. M cube rho v square. Okay, let's see. Again, that same story. So when you take that small l, integral E dot dl is d phi by dt. So here the phi will be b naught t into pi l square. So this is E into 2 pi r is equal to b naught into pi l square. So we get t square, na? That is 2t. So this will be b naught l square time by r. You have an electric field like this. But wait, that is
Already
also L only, na? वो भी, yeah, L भी जाएगा. So B not LT. Now on this particle, if you look at the forces, plus Q and mass M, this will have an electric force, EQ. This will have tension. Now, after some time, you will gain some velocity also. And don't forget, there's a magnetic field now. So that also will give you QE cross P. So there is also a magnetic force. Now here, technically speaking, the time-varying electric field will also create a magnetic field. We're not getting into that right now. Because E bar is changing, that will actually mess up and create another magnetic field. Creates another B bar. We are neglecting it. So I should have given only B not T actually. This is what I said in the beginning. If you have time-varying electric or magnetic fields, it'll start creating the other one. So we are ignoring it for now. And not only this, we also have centrifugal force now, mv square by L. So these are all the forces acting on the system. So tension plus magnetic force must be balancing the centrifugal force. And what is the velocity? We got E here. So force is equal to charge into field, which is mass into acceleration. This is B naught into L into T into Q, mass into velocity is dV by dt. A is not constant. So V is equal to QB naught L by 2m t square. That is your velocity as function of time t. So tension is equal to mv square by L and magnetic force is QVB. Substitute the answer. ये कितना आएगा? Shit, I'm getting T power 4 क्या? QVB में this is also that is also T power 4 only. This is also T power 4 का term. I think in this case, na, tension will come negative. Means rod is not pulling, it is pushing. The rod is getting compressed. You can substitute the values. That is rod is pushing. So that's why it is a light rod. If it is a string, na, the tension becomes 0. Clear with this? So the electric field is making you accelerate. That velocity is creating magnetic force and centrifugal force. Most people, they do forget the magnetic force. So you have to include that. It's a force. Clear? So this part of the field, na, this part is always the easy part. Integral E del d phi by dt. You'll get the field. So only headache was, understanding there is a field and the theory and all is weird. But once you get there, it is just a matter of solving. Next one.
So,
Hmm.
so the rod है वो it is capable of moving, right? The rod.
It
So
fixed किया ना रे God. एक side fixed है.
हाँ नहीं एक साइड फिजिकल ऐसे लाइक मूव कर सकता है ना इलेक्ट्रिक फील्ड के कारण. अच्छा नहीं वो चार्ज से एक ही है वो कुछ नहीं. Okay, I thought एक चार्ज रॉड है. Sorry, कुछ नहीं.
Nee, we just kept a point charge. If you have that thing, then you have to calculate torque on the rod. That would be more fun. You guys will cry, so I didn't give. Clear? Then you'll take find the torque and then the torque is equal to I alpha. Alpha से then omega निकालना पड़ेगा. We'll do something like that. 20th one. A part we will do now. B part I'll give you as a homework. This is another standard question. So we have a charged ring. Insulated charged ring. Neglect gravity. Mass m radius r. So at T0, suddenly a magnetic field is switched on. So initially there's no magnetic field. Constant B is switched on. Matlab, the field suddenly goes from 0 to B in a small time. And when I say that small time, you know what it means. So A part is what? B part is the homework. We'll do same question, but this time it is a charged disk. Yeah. Right, Sana. MR and a disk. Charge Q. So the question is, the moment you switch it on, find omega of the ring and the disk. Find the angular velocity. And ring and disk after field is switched on. Let's do the ring now. Disk, you can try it at home. So initially there's no field, suddenly there's a field. So in that small time dt, something happened. And this ring started rotating. What is the catch? Listen, I'll help you with one. You can try the B part. So the moment you already had 2 minutes. Try karo na. Where did I start? Dekho, itna time instead of discussing with me and arguing, you could have do. And by the time I start, it'll take 2 minutes. So karo na. Or you don't want to hear my explanation? I'll put you on mute.
No.
See, listen, most of you are not getting the idea to start only. So dekho, I'll give you an idea here. This will help you for the B part. So here, magnetic field. See, nothing happens once the B is completely on. Everything happens when you go from 0 to B. 0 to B in time dt. So integral E dot dl is d phi by dt. So this will be E into 2 pi r is equal to, this would be area pi r square into dB by dt. Because flux will be B naught B into pi r square. So the field will be r by 2 into dB by dt. I don't know dB by dt. Now here this dt will tend to 0. So we have a large electric field for small time. So the ring will think someone kicked it. So momentarily during that instant, the ring will experience an electric field this way. A tangential electric field is generated for the small time dt. So torque on the ring will be Q into E into R. But we know torque is nothing but rate of change of angular momentum. QER. So angular momentum is nothing but Q into R into dt E dt. integrated on both sides. So change in angular momentum, Q and R is constant. E is nothing but, so E dt is nothing but R by 2 dB. So change in angular momentum, initially it is at rest, finally it will be I omega. This will be Q R square by 2 integral dB. Now I don't know how the function is changing, but the change in magnetic field will go from 0 to B. I of the ring is mr square. So mr square omega is Qr square B by 2. R square goes off, omega will be QB by 2M. Is that clear? Yeah, so change in angular momentum is torque into time. Is this clear, everyone? So using this as a reference, try it for a disk. That will take time. So take time, spend some time on it and work on it. So that will be one. Let me give you a few more homework questions. The answer you already know. So this is 21. So we have a ring here. On the right side, there's a magnetic field. Left side, there's no magnetic field. So this ring is going with speed v and enters the region. Once it enters, something happens and this thing starts rolling. Ground is smooth. So these are the options. Go through that question later on. This is another question. So try these three questions and come. This is another one which I liked. So we have a cylindrical field region and PQ rod is placed at some weird angle like this. Bubbles means out of the plane. So the question, there are the two options. It is a paragraph question, induced EMF and blah, blah, blah. Check it out. These are good questions. Spend some time. They will take each one. If you spend even half an hour, it is worth it. They will help you to learn a lot of concepts. So try these three questions and come. So on Friday, when we catch up first thing in the class, we will be discussing these three problems. Okay? Yeah, so with that, we'll wrap up for the day. So any doubts in today's class, anything else, you can stay back and ask, or else feel free to leave. So I'll see you on Friday, same time. So take care, stay safe.